something like this. And type 0, of course, you know, you're given the point, so there's not, you don't even have to worry about setting up a table. Okay, so type 3 is a story, and that will be a scenario where you are the question will basically imply or give you at least 2 points that are there. It's gonna hint towards it, and you're gonna have to decide where the third one, or how to come up with the third point. And we're gonna use the axis of symmetry, so it's gonna be you're gonna kind of be familiar with it already. Let me just get this here. So in this case, right, you're provided with 2 points, and you will find the third point using symmetry. That's type 3 in a nutshell. Best way to solve this type is to sketch it first, right? I would say sketch it first, meaning just make a little sketch. Like, it doesn't have to have like scales or anything like that. You just have a little sketch for yourself where you kind of interpret the question. Okay. Remember that the third point will be across the starting point. Okay. And so scenario 1 is where the starting point and the vertex is given. Okay. So I'm just going to give you a quick, this is a very short word problem, right? A ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. It doesn't say that it's 0, 0 as part of this, right? But ball is kicked, right? Assumes ball is on the ground, right? Ball is on the ground. So 0, 0 is very much part of your story here. So I'm going to go arrow like this. It didn't have to tell you that. You just have to understand, right? Interpret the question, and there it is. 0, 0 is right there. What else is it giving us? It reaches a maximum height of 17 feet after 1.25 seconds, right? That should tell you that it's right here. It's the vertex. Okay. So that the time is 1.25 and the height is 17. So you have to make sure you don't mix that up. A lot of students mix the values to put 17 then 1.25. Well, we have time and height there. So that's given there. So where's the third point? Obviously, this is your starting point. So the third point would stand to reason that it would be here across, right? On this leg, it would be here. So I'm going to use a red pen for this and just show you that this is your axis of symmetry here. And we know that this stretch here, how long did it take us? It took us 1.25. So along the x-axis, we traveled 1.25 units. So how many units would it take to get to the other, right across? Another 1.25. Okay? So this point right here is the third point, which is 2.5. And this is the one we need to make sure we understand. We started at 0, right? So we're going to get back to where we're still at the same height, right? So the heights should match. So basically what happened here is you just took that number and you just multiplied it by 2. Okay? And we'll just leave it at that. In this case, if you come up with the table, right, you would have time and height. I would like you to set up a little table like this. So 0, 0 is the first point, 1.25, 17 is the vertex, and 2.5, 0 is my third point. Okay. Notice that, right? I was at 0, and then I'm back to 0, right? Initial height, back to that height when I, so that's the only way you can actually, there's the third point. Third point found right there. Sorry, there you go. And so let's see another example right next to it. I wanted them side by side so that you can see the comparison here. An object is thrown from a height of 8 meters, right? Thrown from a height of 8 meters. So that's it's off the ground, right? It's off the ground, thrown from a height of 8 meters and reaches a maximum height of 13 meters at a distance of 3.5, okay? So this tells me, right, that this starts at 0.8, okay? Page 28. We're at a height of 0.8. And that the maximum height of 13 meters is reached at a distance of 3.5. Let's make sure we understand. Distance is along the x-axis, right? So we need to make sure we go 3.5 and 13 for the height. Right? Get that right. And here's your axis of symmetry again. And then we just decide that, right? There's a distance from here to here and from here to there. We don't go to the x-intercept. A lot of students always want to go to the x-intercept. Yeah, go ahead. So what we know right off the bat is that we started at 8, and if you want the third point, you're going to be back at 8 if you want to use the axis of symmetry. That's very, very important. Okay. So it took us 3.5 meters to get to that maximum height. It stands to reason that it would take the same amount of time to get back to that height, which is 7, right? So we basically just took that and multiplied it by 2 to get that third point. And so if you come up with your table, we have distance and we have height. Remember, it's always x and y. Okay, x and y always. So we started at 0.8, 3.5, 13. Those two were basically given to us. And then the third point is 7.8. And notice that we're back to 8, right? This is the third point. And by the way, could we have used the equation of axis of symmetry to come up with these missing points? Remember x1 plus x2 divided by 2? You could have, yeah. I find it quicker doing it this way. If you want to use the equation of axis of symmetry, you go for it, right? No problem there. So if you're ever doing this on a test, right, this third point, getting that right would be very, very important, right? To get that third point right. Common mistake is to say 7.0, right? Students are like, oh yeah, I'm just going to multiply this times 2 and it's then down here 7.0. Like, that's not right. Look at where you start. It's right across from it, right? So you use the same height as before. All right, scenario 2. So both of these vertex was given, okay? Both of these scenarios, vertex 1 on the ground, 1 off the ground, okay? Now, scenario 2. Start and end point given, no vertex provided. So this is different, right? No vertex provided. So this will be the other way around. On the ground, an object is thrown upwards, reaches a maximum height of 40 feet, lands, and remains airborne for 8 seconds. So that it's kind of implying that we start at 0.0 here. It's thrown up and then stays and hits the ground here at 8.0. Okay, notice that this is perfect, right? You have both heights are 0, right? So that means that they're across from each other. So in this case, you need to figure out the vertex. You know that the maximum height is 40, right? We know that our axis of symmetry goes right through the middle. Right? So if it took us 8 units to get from x1 to x2, right, it would then just stand to reason. You just have to divide this by 2 to get that middle point, right? So you're going to go take that 8, and we're going to divide it by 2 along the way to get our 4. So it stands to reason, and obviously this does not take into account wind or resistance, or we're just assuming that it's symmetrical, right? But if it takes 8 seconds to hit the ground, then it means that at 4 seconds it must have been at the highest point. So that's my third point. So here we go, time and height, 0, 0, 440, 8, 0, right? So this is my third point, the vertex, right? This is the third point, so to speak. Same here. The skier goes down a ramp, 30-foot ramp, it says, right? So that right there is our 0, 30, right? At a distance of 0 at the beginning, you are at a height of 30. The lowest height of 12 feet is reached, lowest height of 12 feet, and reaches initial height at a distance of 50 feet, right? So what it's saying here is that this is your initial height. If you go right across from it, you hit the ground, you hit that same height here. And so we know that it reaches that initial height at a distance of 50 feet. So we know that this is 50, 30 right there. I will highlight this, okay? Reaches initial height at a distance of 50 feet. That's right there. You can highlight that. So this is a little different, right? You have your ramp, you go down the ramp and then up, right? And so in this case, to find the vertex, it's a little cramped there, but we know that it's the lowest height is 12 feet here. Okay? And if it takes us 50 units, in this case, a distance of 50 feet, right, it would take us 25 to reach the middle point. So we get that just by dividing it in half. So here you would have distance and height. It's 0, 30, it's 25, 12, and it's 50, 30. And here I'm going to highlight that again. The important piece of, right, that if you want to use the axis of symmetry, your initial and final height, right, like those need to be the same. But this is my third point right here. Vertex, third point. All right, so this is kind of the strategy I'm going to use over and over again for type 3. Okay, it doesn't cover every single scenario, but most of the scenarios are covered here and on this page before we dive in. Okay, let's go to page 29. Okay, here we go. So Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters and estimates that it reaches a maximum height of 2.8 meters after 0.75 seconds. The container lands on the rim of the recycling bin. The bin is 0.65 meters tall. right? Determine the quadratic equation that models the path of the container, okay? So what I want you to do is always sketch, right? Like make a little sketch and imagine what's happening here, right? So we are obviously relating our time and our height, okay? And we know that it's being thrown at a height of 1.75 meters, right? And then obviously the garbage bin is, or the recycling bin is going to be lower, right, than somewhere in here. So this is what we're given, okay? This is kind of like what's happening here. So write down points that are important, right? At time 0, this is the container, right? At time 0 is 1.75. Can you see that? It's a little small, isn't it? Let me zoom in here. Make sure you get that right. 1.75. So it hits the rim, right? It's kind of saying it's not hitting the ground. Go ahead. It's saying it's not hitting the ground, okay? So we know this point right here is 0.65, correct? Do we know the time? How long it took to get there? Does it tell us at all? Right? Not yet. So how can we find that out? Oh yeah, axis of symmetry, Mr. Dirksen. Obviously. But do you have anything to get you here? You don't have the time it takes to get there. Okay? So what you need to focus on next is the maximum height, right? This here. This right here is your vertex. And so fit that in. So it means that the vertex here is 0.75, 2.8. Okay. So I kind of tricked you a little bit by giving you this here. What you want to do is focus on the axis of symmetry. The initial height is here. You want to find the point that's across right here. You're going to focus on these 3 points here, not that one that I just threw in there. And later on, you'll be able to answer that because once you have the equation, you can, right? So this will be what? 1.75, right? And this will be 1.5, right? Just multiply that by 2. Multiply that by 2 to get that 1.5. And then we figure out our, so it'll be time x, height y. You make a little a chart like this, and you go 0, 1.75, 0.75, 2.8, and 1.5, watch this, 1.75. And this is exactly what you want happening there. Right? You want to get back to that initial height. Type this into L1, L2, and we're going to go stat, calc, 5. Let me zoom out again. I think we're good for zooming in part. And let's do this. Let's type it in. And you're like, wait a minute, what about the third column, Mr. Dirksen? Like, remember, like the first couple? This one doesn't have that. So the story type, you don't have to worry about that. So you just go ahead and type this in, clear everything. Remember, don't press delete. And if you do press delete, setup editor is your friend, right? You just execute that and then you'll be fine. So 0, 0.75, type this in. 1.75, 2.8, 1.75. And then you go stat, calc. I could probably just get it from my home screen. There it is. I'm going to write it down. Negative 1.867 x squared plus 2.8 x plus 1.75. No surprises there, right? The 1.75 We expected that because that's our initial height. So that's the equation. Now we can answer questions. How long does it take for the beverage container to reach the rim of the recycling bin? Now we can answer that, right? Rim, sorry, why, I don't know why I did that. The rim is at a height of 0.65 feet, right? As per the question up there. So we know that we want to go y2 is equal to 0.65, and then we're going to find the intersection between that line and the parabola. So let's go ahead and do that. Yeah. Or I'm wrong.
No, you're not.
Yeah, it's just a typo. Okay, so Zoom 9, this one works pretty good. Zoom 9 with a story type most of the time works quite well. I'm just going to go and go -2 here. X max, I'm going to go maybe 5. Y min -5. Y max, I'm just going to keep it at 5. And remember, we focus on the first quadrant in this case. So let's go ahead and find that. So y2 is equal to 0.65. There it is. So it happens right there. Second trace 5, enter, enter, enter. And the answer is 1.82 seconds. How long does the container remain below 2.5 meters? What I'm going to do here is the wording is key here. What can I say? Below. So I'm going to go total air time, right, minus time at or above 2.5 meters. So let's go ahead and, do you remember how to do these ones? We got to go y2, we got to make that 2.5, right? So I'm going to figure out, I'm going to take the total airtime. What's my total airtime, by the way, in this case? When does the airtime end? When the beverage container hits the rim, right? Like it hits the rim of that. You know those blue containers that have like, they just have like a little round hole at the top? That's kind of what I was envisioning when I wrote this question. So it kind of landed there, didn't make it into the bin, right? It kind of just landed on the rim. Okay. So total airtime is actually this, right? This is actually total airtime. So we're going to go 1.82, right? Minus the time at or above 2.5. Why are you doing that, Mr. Why are you making it so complicated? Well, it says time below, right? 2.5. So I'm going to focus on at or above and subtract that. And so all that remaining time must have been below the 2.5 meters. So watch this. Give me a little diagram here on the side. Let's do this again. Actually, let's start off higher this time here. it hits the rim right here. But there's a 2.5 meter line. Okay, so we're gonna figure out how much time went by. Right, there's a time 1 and there's a time 2 here. There's a certain amount of time that went by. Okay? So let's go ahead and find that. Second trace 5. Let's find the first intersection. That's 0.3491. Remember 4 decimals here, right? We're going to subtract them. Enter, enter, enter. The second instance is 1.1509. This says 3491, if you're wondering. This right here, 3491. Delta time is simply subtracting them, right? So delta time is, let me check my notes here. Here we go. 0.8018 seconds. And that we have to make sure we understand what's happening here. Put a label, time at or above 2.5 meters. And this is where highlighters come in. Right, this time right here that you just figured out is the time at or above. Right? That little stretch that it went above and beyond. Okay. So we're gonna take the total air time, like from the beginning all the way to hitting the rim. We're gonna take that whole air time and subtract it from it. Right? So we're gonna take this with us here, 0.8018. And you're probably wondering, but Mr. Erickson, why are you using a 2 decimal number and then a 4 decimal here? What's happening? Well, I'm using the answer from a previous section, and then you get to do that, right? You use that answer, you bring it in here. And we're not going to get too technical here. If you were to use 4 decimals again, I would not take marks off. So the answer is 1.0182, which is approximately 1.02 seconds. Let's make that pink or something. Whatever highlighter you have, that's this here. That time and this. So what can I say? Just read your question carefully. Wait. Could I have done this? Find the time from here to here. Put it aside. Then find the time from here to here. Put it aside, and then add those two up. Yes, you could have. Yeah. The only thing is then you would include the time at or below 2.5. And we just want below. So I actually found at or above, subtracted it from the total, and then get the pink time, which is all the stretch, right? The time where it was below. Let's graph it. The funnest part of all, right? Yes, you like graphing. By now you should be pretty good at it. So this is time in seconds. We're gonna have height in what are we in here? Meters. And you need an appropriate scale. Along the x-axis, it takes me to like 1.82. So I have lots of room. So let's go 0.5 here. 1, 1.5, 2, 2.53, that's the plenty, right? So I'll leave it there. And along the y-axis, what should I use there? I'm going all the way to 2.8. So if I go 0.5, 1, 1.5, 2, 2.5, 3, that works pretty good. So I'm going to go 0.5, 1, 1.5, 2, 2.5, 3. Try to use as much of, if you have a grid, use it as much as you can. So we start at 1.75, which is right there. The vertex is at 0.75, 2.8, which is just past 2.75, right? And then 1.5, no, sorry. Yeah, 1.5, 1.75, we can graph that again. But you got to make sure the story is in here. So in this case, you would want to use the 1.82, 1.82, 0.65. You would want that on there. Okay. There you go. Oops, 1.75, right? Take a moment to graph this properly. And your domain and range. Give it a try. I'm going to let you do that first. There's lots of room, so if you get it wrong, cross it off. But would you be able to state the domain and range right now? I'm going to add another one in as well, another question here. Get you thinking a little bit. So F time, we're going to shorten this, right? Time at or above 0.8 meters. Would you be able to answer that? Time at or above 0.8 meters? I'm just going to state the domain and range already. This one is the trickiest one, right? The range. That's the lowest. And that's the highest, right? So if you want help with the range, you go to your graph, you make a line, like a very, very light line, right? Like you're like, okay, it's from here all the way to here, right? Like, and then you kind of figure out these y values, and that's that. This one I just made up, f, right? So here, I hope that you understood that you had to do that, right? And what do you notice there? Does it hit it more than once within quadrant 1? It doesn't, right? You notice that? So in this, it's actually easier. It's actually it starts at time 0 until it hits that, right? So all you need to find is basically the time there. So second trace 5, enter, enter, enter. Don't worry about the negative. That'll be 1.79 seconds. That's it. So if you were trying to find the other one, it's okay. You know what? Like, I actually wanted that to happen, perhaps, like for you to think, should I not? Maybe I will, right? Just to realize that in this case, right, it's right there. So don't worry about the one over here, right? This one we omit, right? We omit. So it just starts at time 0 when it gets thrown up, and then it hits there. So that's the time it was at or above. All right. So I wanted to remember solving quadratic equations with a quadratic formula. Remember that one? Quadratic formula? You loved it, right? Yeah, you did. Let's go there. I just wanted to show something that's actually pretty cool. If you go to page 36, I'm not going to spend a whole lot of time. I just wanted to show you that it works. Page 36, we use the quadratic formula. By the way, make sure this is on your study sheet, right? What did we do with it? Like, what did that give us? It would find the x-intercepts, the roots, the zeros, or also known as the solutions, right? And it really allowed us to solve a quadratic. And when you solve a quadratic, this is on page 36, y is equal to 0. Okay. What I want to explore with you is, let's go to page 37 real quick here. Go to page 37. Oh, that one didn't have roots, so never mind. That's not a good example. I want to show you, if you go to page 38, that one is a bit scary for today. Or maybe I'll just leave it for today. I'll just leave it. I feel like I'm going to rush it and then it's going to backfire. We'll just go back to page 29. It's right there. Those pages basically cover not just type 3. There's a little bit of type 0. But even if you did the homework from the past, I mix it up. I start mixing it up, so it's good practice. Okay. All right.